So, after discussing the life cycle of Plasmodium ilex and Plasmodium falciparum, now I'm going to discuss about the morphology of this particular parasite. Malarial parasite, trophozoites. So, what are trophozoites? So, trophozoites are a growing stage in the life cycle of some sporogenous parasite that are generally ring-shaped and their size is 1 to 2 micrometer. Mostly found in ring-shaped, but there are some other shape like a band-shaped or amoeboid-shaped may also exist. So this sexual form of the parasite, the gametocytes, both male and female gametocytes, that is actually coming from the human to the mosquito. They are of relatively larger size, and here the size is 7 to 14 micrometer. So this picture tells you about the set of different types of Plasmodium species. So this one, which is the longest one and the banana-shaped one, is the Plasmodium falciparum, and the others are relatively smaller and round-shaped. So oval, then malaria and ibex. They are of different shapes. You can see here. So Plasmodium falciparum is the most severe agent, most severe means the most deadly agent of malaria. They have this particular shape that is banana shaped. Now, how this is very important that how this uh, neurozoid they are actually uh, interacting with the red blood cells means the mechanism of RBC invasion by a Plasmodium falciparum merozoite. So host cell recognition is a prerequisite. So host cell recognition and species specific attachment and reorientation are likely mediated by some species specific proteins that are known as species-specific adhesion, and these adhesion proteins are spread here. You can see they spread throughout the surface of the merozoite. This pink and red dots. These are actually the species-specific and blue and red dot. These are the species-specific adhesion, and these adhesions are responsible for the adhesion or attachment of the merozoite with the red blood cells. So there are some receptors also that recognizes the RBC surface receptor, and this specific attachment and recognition are likely mediated by several low and high affinity binding adhesions. So this affinity is species specific. In few species the affinity is very high, in few species the affinity is very low. So this low and high affinity binding adhesions that dictate host cell specificity. So when apically juxtaposed means here you can see this is the apical one means invagination of the plasma membrane here. Apical juxtapose means this placing of two layer or two surfaces, one of the from merozoite, one from this plasma sorry RBCs. So these two surfaces or two elements, they are close together or side by side. They're placed close together or side by side. So this formation is known as apically juxtaposed. The rotary neck derived protein complex, which is known as the RON complex. Here you can see the RON complex These are the Ron complex. This brown color components are the Ron complex. Here I have also marked the Ron complex. So this Rhabdoneck-derived protein complex can be translocated into the host cell to act as a receptor for apical membrane antigen 1, that is the AMA1 apical membrane antigen 1, or the apical membrane antigen 1 like protein. So at the apical tip, so they are present at the apical tip. Here you can see this pink colored protein and the signals here. These are the two signals you can notice. So they are present at the apical tip, and uh, this interaction allows intimate contact between the RBC and the merozoite, which means between the host and the parasite. And this particular junction is known as moving junction. So this particular junction provides a strong anchor point on the host cell, and it is actually developing endocytosis. So during invasion, the actomyosin motor here, this myosin you can see, this myosin is present there. This myosin. So this enlarged picture you can see the myosins present there. These black dots in myosins. So this actomyosin motor utilizes the moving junction, means here, this moving junction utilizes the moving junction here, attachment between the apical site, utilizes the moving junction as a traction point to drive penetration. So it will penetrate, means the merozoite is coming inside with, in the forming a vesicle like structure. So to drive penetration, and the AMA1 cytoplasmic domain. So AMA1 cytoplasmic domain could play a direct role in connecting to the innovation motor, or act as a signaling component to coordinate this process. So this is how you can see this RON complex and AMA protein and the presence of myosin motors. They are actually dragging the merozoite within the red blood cells. So this is the mechanism. There are several mechanisms. This is one of the mechanisms I'm showing here of RBC invasion by the Plasmodium species. Now I'm going to discuss about the mode of transmission. Here the mode of transmission is malaria spread only by the mosquito bite. Other transmission methods are also there, that is from mother to unborn child, then through blood transfusion, and also by sharing needles used for mostly injecting drug molecules. So these are the modes of transmission of malaria or Plasmodium parasite. Now, what are the clinical symptoms? So there are two types of symptoms. One is the early symptoms, and the second one is acute symptoms. So in case of early symptoms, so these are headache, malaise, means overall discomfort of the body, then fatigue, nausea, vomiting, muscle cramp or muscle pain, then slight diarrhea and fever. These are the early symptoms. Then anemia due to disintegration of RBCs, and then jaundice and hepatosplenomegaly due to infection of liver of the host, and respiratory distress syndrome and renal dysfunction can also be seen in case of acute illness. Now we can say that about the discovery, disease severity and duration. So four different species of Plasmodium uh, can infect human being from moderate to severe. So you can see in case of Vivax and malaria, the infection is moderate to severe, whereas in case of Ovel, this is mild, and in case of falciparum, it is always severe. That is why more importance should be given from to study about Plasmodium falciparum. And here you can see that the symptoms can be developed within 2 to 3 weeks in case of falciparum on the oval, but in case of Malaria and vivax it took 3 to 8 weeks. And this is very important. Development of anemia in case of falciparum is more high, more severe, and also cerebral complications can also be there in case of Plasmodium falciparum infection, but which is absent in case of the other three. So this the is why this table tells you about the severity of Plasmodium falciparum infection. Now, laboratory diagnosis. So mostly carried out blood film or blood smearing, and by checking the active parasites or else the disintegrated red blood cells. So health agencies and volunteers treating fever cases in case of malaria detection. So they mostly use the RDT, means rapid diagnostic test kit. Nowadays, falciparum specific so far and now bivalent RDT that detects both vivax and falciparum, as well as mixed infection for the diagnosis of malaria cases is available. So the kits are available to detect both or different types of Plasmodium species. And if you go for further study, you can go with malarial fluorescent antibody test to confirm uh, malarial presence, means Plasmodium species present or not. But 2 weeks or more after primary infection. So this is the drawback that after primary infection, so you have to wait for at least 2 weeks. Then only you can have sufficient amount of antigen that is present there in the blood. So then you can go for fluorescent antibody testing that is malaria specific, and definitely you will get this. This can be used as a confirmatory test for the diagnosis of malaria. Then treatment. So mostly the quinine or quinine derivatives like chloroquine, then tafenoquine, then nalarone or halofantrine. These are the molecules, drug molecules that can be used for the treatment of malaria. Uh, but the notion is there that prevention is better than cure, so we can prevent this particular disease, taking some preventive measures like using mosquito repellents. So DEET is an established mosquito repellent. There are some herbal oils in the form of essential oil can also be used, like tea tree oil, citronella oil, neem oil, etc. can be used as a mosquito repellent. And to combat against malaria, so you have to wear long pants and long sleeve shirts. Then light color clothes is preferable rather than the colors dark colors. uh, so you can use window screen or nets can be used. And mostly this mosquito bites at the night, so when you are sleeping always you wear nets. So insecticide treated nets ITNs can also, it is also available, and you can also use this. This is also helpful for to combat against this particular vector, means anomalous mosquito, and to prevent spreading of this particular disease. So also you can go for a different eradication plan, like you can go for pest control management system using DDT, using other pesticides also. And this is the integrated vector control cycle, where you can use some chemicals, you can use biological method. You can also go for the treatment against the anti-larval and anti-adult mosquito. Then personal protection, you can use nets, you can use repellent, oils, creams, and you can use some spray uh, like malathion, pyretrum, DDT, etc., uh, to treat against the adult mosquito. And you can use some mineral oil, you can use malaria again also. This is vaccinated. So in case of the anti-larval measures, environmental control, which is temporary, permanent both can be there. So good water management practices are best. So this should be followed. In case of biological control, some insects, some protozoans, species, arthropods, bacteria, fungi, they are helpful in this biological control. Genetic engineering can also be a tool, like using transgenic mosquito, must be the male mosquito, infertile male mosquito met with the female mosquito partner. So by genetic control, you can also control this particular disease spreading. And okay, the last one is a clinical control. Is given high priority on operational measures. In case of biological agents, as I said, the fishes like Gambusia, guppy, these are the fishes can use, and they prefer mosquito larvae as well feed. And also some bacteria like Bacillus thuringiensis and Bacillus sphaericus, they can be used for the as a biological agent for the control of vector population. Uh, then malaria vaccine for the treatment purposes. There are three different types of vaccine which are not in market, are in the clinical trial. So these are the three stages, three target site. This picture will tell you about what should be the target site. So you can target here anti-sporozoite vaccine, then liver stage vaccine. You can target the merozoite, either the sporozoite or the merozoite, or else you can go for blood stage vaccine. You can target again the merozoite to convert into gametocytes. Then the sexual stage vaccine, where you have to combat against or function against the gametocyte that they should not mate with each other to form uh, the gametes or else the ookinetes or oocysts. So this is the way you can prepare vaccine. So SPF 66, the first malarial vaccine that was tried in clinical trial in 1990s, and the second one is RTSS, and S, the most successful vaccine candidate. So this is all about malaria and the spreading. There, how can we stop their spreading? How can we combat against the particular disease? That's all.